folks. We're going to get started in about a minute. Welcome to the stream. All right, welcome folks. We're going to get started. Today is day 16 of remote learning. Today's joke is, who can jump higher than a house? Pretty much anyone. Happy Wednesday. Evaluate that like button to show your support. Thank you for filling in the survey. Got lots of really useful feedback from it. People were asking for shorter streams, shorter homework, some more written explanations, and some earlier stream times. So I'm going to try over the next week to incorporate as many of those as I can. The one that I need some information from you about is shorter stream times. And so I'm going to wait until a little later in the lesson. I'd like us to get to having about 10 people in the chat at least before we take a vote. We're typically having 10 to 14 people follow along with the live stream. So I want to ask those people whether they would prefer 9 a.m., 10 a.m., or 1 p.m. lessons. I can't do 11 a.m. because I already have my grade 12s at that time. But if you would prefer that we change the lesson time to 9 a.m. or 10 a.m., we'll take a vote on that a little later in the lesson. And I'm happy to do whatever time works best for the people who are attending. Okay, so today we are going to go back and redo a skill that we've talked about and actually even done on a test already. And then we're going to add to that skill. So the skill that we're going to redo is looking at how to build an equation given some information about the relation. And eventually we're going to use that and we're going to start building equations about given information about parallel and perpendicular lines to that one. So that is the information that we're looking for. One of the other recommendations that I got in the survey was to use a, not to use pencil, so to use something that's darker and a little bit better contrast. So I had this really nice black pen that was working really well, and now it's closed up and it's not reopening. So we will see if the blue one will work instead. Okay, so we're going to start. And as I said, this is a bit of a review. These things should look familiar to you. You may not remember exactly how to do them, but hopefully it seems familiar. So our first example, a relation has slope 1/5, so it goes up 1 and over 5, and y-intercept of 7. And we're asked to write the equation. And so you can take a moment, give that a try. If we know that a relation has a slope of 1/5 and a y-intercept of 7, can we write the equation for that relation? Once you have it written down, you can send it into the chat and I'll take a look at them. Alan, you've done everything right, but in order to make that into an equation, you have to add a little bit extra. Same for you, Jordan. You've done things correctly, but we want an equation. What you've given me there is an expression. Thank you, McPickle. Let's see if we can get one more. Yeah, that's exactly it, Jordan. Okay, so we know our slope is 1/5. So solving this, we have m equals 1/5. We know our y-intercept is 7. B is 7. We know that our pattern for linear relations is y equals mx plus b, at least in slope-intercept form. And so then we can just sub in m is 1/5, x plus b, b is 7, and we get y equals 1/5 x plus 7. And we're generally going to be trying to do this. Figure out what the slope is, figure out what the y-intercept is, use those two pieces of information to write the equation. We do often end up in a slightly trickier spot. So we'll do example 2 here. So in this case, we know that a relation has slope 2/3. But we don't know the y-intercept for this one. What we do know is that it passes through the point 6, 7. And for all of these questions, we're assuming that this is a linear relation. So it goes through the point 6, 7. We want to write the equation. So this one, we know m equals 2/3. We don't know what b is, but we have a pair of xy values. When x is 6, y is 7. And we can't use those independently. All right, y isn't 7 all the time. X isn't 6 all the time. But when x is 6 in this relation, the corresponding y value is 7. And of course, we know, as always, y equals mx plus b is our pattern. So now we can fill in those three values into our pattern. So y is 7, m is 2/3, x is 6, and we don't know what b is, and that's what we'd like to find. So now we have an equation. It has only one variable in it. Everything else is numbers. So we can just go through and solve. So now solve. Well, 2/3 times 6 will make it 6/1. So it's a fraction. Fraction multiplication, we do numerator times numerator. 2 times 6 is 12. Denominator times denominator. 3 times 1 is 3. Plus b, well, that's going to be 4. 12 divided by 3 is 4. Oh, and you can't see me anymore. There we go. And then we're going to subtract from both sides. 7 minus 4 equals 4 plus b minus 4. And we end up with 7 equals b, or b equals 7. So now we can say the equation is y equals 2/3 x plus 7. So this is more typical of the situation where we're going to we know 3 of y, m, x, and b, but we don't know both m and b. So we know all of them except m, or we know all of them except b. Then we can sub in what we know and solve to find the last one. All right, give me a 1 in chat if that's making sense, or if you have a question, now is a great time to ask it before we go on to the next one. Thanks, Jordan. Thanks, Owen. Okay, Jackson, I'll give you a quick summary. So earlier in the course, Jackson, we did a skill kind of like these where we said, okay, if we know some information about a relation, how can we write the equation of it? So if we know, for example, the slope is 1/5, the y-intercept is 7, well, that means m, because it's the slope, is 1/5, b, because the y-intercept is 7, so we can write the equation, y equals 1/5 x plus 7. The other one that we did together earlier in the semester is we said, okay, what if we have 2 points, not just the slope and the y-intercept, but what if we have 2 points? Can we use that to figure out the equation? And so I'm going to give an example of that now. Eventually, what we're trying to get to, Jackson, is if we know information about parallel and perpendicular lines, can we write an equation? So that's our goal. Okay, so I'm seeing a few people saying 1 in the chat, that they're ready to move on. So let's go and look at example 3. So if we have a linear relation and it passes through 2 points, and in this case I'll use 6, 7 and 12, 2. And then we want to figure out, write it down here, what is the equation? And so again, we know our pattern is y equals mx plus b. So if we can figure out m, the slope, and we can figure out b, the y-intercept, then we're good. Oh, Emma, an excellent question. The reason b doesn't equal 3 is that I messed up. B should absolutely be 3. And that will change our equation here. Thanks so much for catching that, Emma. You are absolutely correct. All right. So we know y equals mx plus b, but we don't know the slope m. We don't know the y-intercept b. We do have a point x and y. In fact, we have 2 of them. We know if x is 12, then y is 2. We know if x is 6, then y will be 7. So now we need to figure out, well, how can we find the slope? Well, we know that the slope is the change in y divided by the change in x. And we know change is final minus initial. So y final minus y initial divided by x final minus x initial. Okay, so maybe I'll call this the initial point, and this one the final point. So my y from the final point is 2. My y from the initial point, that's 7. So we have 2 minus 7. X from the final point is 12. X from the initial point is 6. And now I can just evaluate. 2 minus 7 is negative 5. 12 minus 6 is 6. So now I know that my slope is negative 5 over 6. All right, I'm going to pause there because I want to talk about this for a moment. On the second test that we did, just like the Thursday or maybe the Wednesday before March break, so just before the break, a lot of students would get this far and then they would plug this into their calculator. They go, okay, negative 5 divided by 6, that is negative 0.833333333 forever. So I'm just going to round it to negative 0.8. We really don't want to do that. The reason is that if we round the slope, when we do calculations to find points, the answers we get are not going to be exact. And the bigger the x value that we're using to try and find a point, the less correct or the less exact our answers are going to be. So we don't want to round this to 0.8. We also can't write an infinite decimal. Like we can't write all the 3's because there's infinitely many of them. So our solution to this is to just leave it -5 over x as a fraction and not change it to a decimal. And so I would highly recommend that if anytime you get a fraction as a final answer, just leave it as a fraction. Don't change it to a decimal unless there's some compelling reason for doing so. Okay, so now we know that m is -5 over 6. And now we're in good shape to go through and figure it out. Because y equals mx plus b, we have an x and a y. We have an m. B is the only thing missing, so we can sub in. So y, I'm going to use this point. You'd get the same answer if you used that point. Y is 7 equals m is -5 over 6. X is 6 plus b. And then I'm going to give you some time to solve that, see what you can get. And when you solve it and get the value for b, please put the answer in chat. Move that up in case you need to see it. So we have 7 equals -5/6 times 6, or 6 over 1. Can you go ahead and solve and find the value of b that we need to add to make both sides equal? All right. Got some suggestions, 2 and 12. Cool. Cooper, I think that you've done the process correctly, but you might have a sign error in there. I think your -5 might have become a +5 along the way. Ravneet, that looks correct. Cool. Nice, Cooper. All right. So for those looking to see how it's done, this is what we have. We want to solve it. So we do the multiplication. -5 times 6 is -30. 6 times 1 is 6. -30 divided by 6 is -5. So now we have 7 equals -5 plus b. If we add 5 to both sides, we're left with just b on the right. 7 plus 5 is 12 on the left. And so b equals 12. Okay. So here we go. We get b equals 12. And now we can conclude the equation is y equals negative 5 over 6x plus 12. And it's worth thinking about why we don't fill in numbers for the y and the x. Take 10 seconds and think in your head, why do we fill in numbers for the m and the b, but we don't fill in numbers for the y and the x? Okay, so the reason is that we're looking to write a relationship between x values and y values. So x can be any number, and we want to find the y that's related to that x value. So if we pick a number for x, we're going to get a number for y. If we pick a different number for x, we will get a different number for y. So we don't want to fill in one particular pair. We want an equation that represents all the different pairs. We want an equation we can make a table from by putting in different x values and calculating the corresponding y values. Okay. So we're going to move along here. In some ways, these get a little trickier because now we're into new territory, but in other ways, you'll find they get actually quite a bit shorter to do. So example 4, we have a relation is parallel to y equals 2 over 7x plus 9 and has y-intercept, we'll just use the letter b, equals 21. Find the equation. I'm just going to write FTE for find the equation. So y equals mx plus b, that's our pattern. We don't know the slope for our equation, but we know that it's parallel to this equation, to this line. And so now we need to think, okay, what does it mean to have a parallel equation? Well, it means that they're going to have the same slope. That's what we learned in the last lesson. So if they have the same slope, then I can just look at the slope of this one, and that's going to be the slope for the relation I'm trying to find. So I can say, okay, m is actually going to be 2 over 7. And b, well, the question told us that the y-intercept is 21. So therefore, the equation is y equals 2/7 x plus 21. So lots of good information here. If we know that two relations are parallel, then we know that their slopes have to be identical. So if we have the slope of one, we can use that as the slope of the other. Okay. So you can see this is a new skill, but it really builds on what we've already learned. I'm going to do one more example. If you have questions, feel free to type them in the chat. After this next example, I will stop and take an extended time for people to put their questions in. So we're going to do a slightly trickier version that uses another skill we've learned. We're going to stick with parallel. So relation is parallel to, and the reason this question is trickier is that it is going to be an equation that's not in slope-intercept form. So we have -3x plus y equals -4. So we know that's parallel to our relation and has, and passes through the point 8, 19. So again, we know about parallelism. We don't have this equation organized quite the way we want. And instead of having the y-intercept, we have an x-y pair. So we're going to use the same idea. We're looking for y equals mx plus b. we know that when x equals 8, y is 19. So that's a pair that goes together. We don't know the slope, though, because we can't see the slope here very easily. Josh, which formula are you asking about? Are you asking about the formula for slope from 2 points? Are you asking about the y equals mx plus b? I'm going to keep moving, but I'll keep an eye on the chat, and once I know which formula you're asking about, then I'll go through it. All right, so we have a point, x equals 8, y equals 19. We'd like to get this relation into slope-intercept form. And so you might remember a few lessons back, we were going from standard form to slope-intercept form. So we're going to do that here. This one's in standard form. And we want slope-intercept form so we can see what the slope is. So what I'm going to do is I'm going to add 3x to both sides of this. And remember, we're always doing the same on both sides, just like when we solve. So now minus 3x plus 3x, that's 0. So all that's left over here is y. And here we have minus 4 plus 3x, or if we switch the order, 3x minus 4. And that lets us see that the slope is positive 3. You can notice it's really important to get it into slope-intercept form, because if we just looked at the coefficient of x in the original equation, it's negative 3. Negative 3 is not the slope for this relation. The slope for this relation is actually positive 3. So we really need to get things reorganized to slope-intercept form before we take the slope. Can I explain the formula for slope? Yes. So I'll just do it on a little piece of paper here. So you might remember, Josh, that we said that slope, if I have a table, so if I have like 1 and 5, and here for 1 it's at 11, for 5 it's at, let's say, 3, that I look at how much it's gone up or down by, So 11 went down 8 steps to get to 3. 11 minus 8 is 3. And 1 went up 4 steps to get to 5. 1 plus 4 is 5. And then to find the slope, we say, okay, it's the change in the y, which in this case is negative 8, divided by the change in the x, which in this case is 4. And if we put that into lowest terms, the slope for this relation would be 2. So that's doing it from a table, which hopefully is a little more familiar. If we want to write that as an equation, we're actually going to go 3 minus 11. 3 minus 11 divided by 5 minus 1. And 3 minus 11 is going to tell us that it went down by 8, going from 11 to 3. And 5 minus 1 is going to tell us that we went up by 4, going from 1 to 5. And so that gives us negative 2. So there's your explanation for the slope formula, Josh. Do let me know if there's other things you're wondering about that. Okay, so back here, we figured out that our slope was 3. We know our x value. We know our y value. We can sub those in. So y is 19, m is 3, x is 8, plus b. 3 times 8 is 24. I'm going to leave some space here because I know I'm going to subtract 24 on both sides. 19 minus 24, that's negative 5. 24 minus 24 is 0. So b is all that's left over here. And we have b equals negative 5. And now we can conclude that the equation is y equals 3x, because our slope was 3, minus 5, because our y-intercept is negative 5. Okay, I'm going to pause it there. If you have questions, now is a great time to ask them. And then we'll do one more example using a perpendicular slope, or a perpendicular line. And we'll see how we do things when it's perpendicular instead of parallel. Oh, good, Josh. Glad that made sense. Okay, just type a 1 in the chat if you're feeling comfortable with what we've done so far and you're ready to move on. Okay, good question, Alan. How did I find B? So, Alan, if you're comfortable with how we got the slope, that we know they're parallel, so we took the equation and rearranged it into y equals mx plus b form, into slope-intercept form. And then there you have to have the same slope because they're parallel. So then I went back and I said, okay, now it's like I have the information m equals 3 along with x equals 8 when y is equal to 19. So Alan, I can put those three things in. Y, that's 19. M, that's 3. X, that's 8. And then solve this equation for b. And that's how I'm going to find the y-intercept. So Alan, let me know if that makes sense or not. Ravneet and Emma, thank you for letting me know you're ready to keep moving. Cool, thanks, Alan. Okay. So now we're going to take a look at our last example, example 6. And for example 6, we have a relation. I'm going to specify linear. All of these, we've meant them to be linear. So we have a linear relation, goes through -6, 11, and is perpendicular to 2x plus y minus 9 equals 0. I don't know if you can hear scratching in the background, but I think my cat's trying to get in. All right. So perpendicular 2x plus y minus 9 equals 0. Well, we know from perpendicular things that the slopes are negative reciprocals of each other. That means if you flip the fraction that's the slope and you change its sign, so one of the two is positive, then the other one's negative. If the first one is negative, then the second one's positive. So you flip the fraction and change the sign, then you'll get the perpendicular slope. And that's exactly what we're going to do here. So we're going to say, okay, 2x plus y minus 9. We want to arrange this in slope-intercept form so we can see what the slope is. So I'm going to add 9 to both sides. Now I get 2x plus y. Negative 9 plus 9 is 0. I'm going to leave some space here that I'm going to fill in later. 0 plus 9 is 9. So now I want y equals. I have 2x plus y equals, so I'm going to subtract 2x from both sides. 2x minus 2x is 0. All that's left is y. And then over here, I'm going to change the order. Minus 2x first. The 9 is positive, so it's plus 9. There. So now I have y equals negative 2x plus 9 as the equation that is perpendicular to the one I'm looking for. So the slope of the perpendicular line, and I tend to use this little symbol here to mean perpendicular, is -2. Or if I make that into a fraction, -2/1. Therefore, the slope we're looking for is flip and change the sign. So this is negative, so it's going to become positive. And when we flip, we get the 1 on top, the 2 on the bottom. And so our slope is now 1/2. So now I know for my line, my relation to be perpendicular to this one, my slope has to be 1/2. So, okay, now I have m equals 1/2, x equals -6, y equals 11. And this is a pair, x and y, right? Y is only 11 when x is -6. Now I can put all of these things into my pattern y equals mx plus b. So y, that's 11. M, that's 1/2. X is 6 plus b. And if I solve this, I'll get the value for b. So you can follow along as I solve it, or you can try it on your own. Cooper, can you explain how you got m again? Yeah, absolutely. So Cooper, hopefully you're good with how I rearranged to get the slope-intercept form. Right? I took a standard form equation, I did the rearrange. We did that a few classes ago, some practice to get it rearranged into slope-intercept form. So now that it's in slope-intercept form, I can see the slope. The slope here is going to be -2 for this relation. The relation we're trying to find is perpendicular to this one. If it was parallel, well, then I would know that it had a slope of -2 as well, because parallel relations have the same slope. But it's actually perpendicular. Since it's perpendicular, I can take the original slope of -2, made it into a fraction. I just put it over 1. And then perpendicular slopes, we know you have to flip and change the sign. The technical term is negative reciprocal. So I'm going to take this fraction and flip it. So the -2 is going to go on the bottom, the 1 is going to go on the top. And I'm also going to change the sign. So the negative is going to become positive. This fraction is overall positive, whereas this fraction was overall negative. So Cooper, let me know if that helps you to see how we got the 1/2 in this situation. All right, so while I'm waiting to hear back, just going to continue on here. So we have our slope of 1/2. Great, thanks, Cooper. We know that when the x value is -6, oh, I'd better put my negative there. I'm going to run into trouble. Our y value is 11, so we can put in x and y. And we don't know b. We're going to try to find it by solving just like we have. So put this over 1. 1/2 times 6, 1 times -6 is -6. 2 times 1 is 2. So we get -6/2 plus b. -6/2 is just -3 plus b. And now if I add 3 to both sides, then I get 14 equals b, or b equals 14. So therefore, I can write the equation. The equation is y equals, my slope is 1/2, so m is 1/2, x plus b, well, I know b is 14, so I can put 14 in there. So I just want to show you one more quick thing with this, which is if I pop over into Desmos and I put these two equations into Desmos, I can check whether my answer is correct. So my original equation is 2x plus y minus 9 equals 0. Oops, sorry. Minus 9 equals equals 0. The point we had was negative 6, comma 11. And the new equation that we got is y equals 1/2 x plus 14. And I'm just going to zoom here and then bring the Desmos so you can see it. All right. So hopefully this is pretty visible to you. You can see here in red, hopefully that's in view. In red here we have the original line, 2x plus y minus 9 equals 0. You can see that it is perpendicular to our new line, y equals 1/2 x plus 14. And I also marked the point negative 611 just by typing it in as a point. And so we can see that our new line is both perpendicular to the old line and goes through the point negative 611. And we can see a lot of things about this new line. Its y-intercept is indeed at 14. Each square is worth 2. So this is 10, 12, 14, 16, 18, 20. So we're at 14. And it's going up 1 over 2, up 1 over 2. So our slope is 1/2. All right, so I haven't been able to look at the chat for a moment. Get back in there and see what you have to say. All right. So hopefully you found that useful. It builds on a lot of skills that we've done so far. Before we close out, I want to ask a quick question. So we have the option of moving the stream to earlier in the day. And in the feedback survey, a number of people told me they'd prefer to have the stream earlier in the day. So what I'd like you to do is to type in the chat 3 things: 9, 10, and 1, and just put a period in between, or a space is fine too, and show them in order of preference. So if you prefer that we do a stream at 9 a.m., and your second choice is 10 a.m., and your third choice is to keep it at 1 p.m., you would write 9.10.1 or 9 space 10 space 1. If you prefer the 1 p.m. stream, and then 9 a.m. is your next choice, and then 10 a.m. would be your third choice, please put 1, 9, 10. If you only put one of the 3 choices, it doesn't let me know whether you prefer, like let's say you say 9 a.m., that's my favorite. It doesn't tell me whether if we can't do 9 a.m., you would prefer to keep it at 1 or you're good to move it to 10. So that's why I really appreciate you putting all 3 of these in here so that I can see what the preferences are. All right. Thank you, Alan. Thank you, Cooper. Thank you, Emma. Thank you, Jordan. So I can see we've got 9 or 10 people in the chat. If you can let me know, because I'm going to make a decision based on this. So I'd like to have information from as many people as possible to make sure that I'm doing something that's good for lots of people and not just a few. So please let me know. Type the 1, the 9, and the 10 in whatever order is your preference. Your first preference first, your second preference next, and then your third preference at the end. Thank you, Ravneet. So you prefer the 1 p.m. time and then 10 and then 9. All right, so right now we're about half and half. We have 3 people preferring 10 a.m. We have 1 person preferring 1 p.m. I'm going to wait and see if there's any other answers. I know we have 10 people in the chat or watching the stream and only 5 answers. So if you're watching, if you could please let me know what your preference is. If you don't care if any of those 3 times are good for you, you can just type no preference into the chat, and that way I'll know that any of those are fine for you. And we'll go from there on. So while we're waiting for those last few, if you have any questions about what we've done today, feel free to let me know. In the Google Classroom, I've posted the page from the textbook with questions. It's 32 through 37. And so that's 6 questions for you to try. And they're all this type of question where you have some information about a relation, including parallel and perpendicular information, and you're asked to create the equation. Thank you. Okay, still 5. All right, we still only have 5 people. McPickle and Josh, I know the 2 of you are in there as well. If you do have an opinion, feel free to let me know. If you don't share it here in the chat, but by email, you're welcome to do that as well. Please check back in the classroom tomorrow. I will post there to let you know what time Friday's stream is at. If the information I have doesn't change, I think we're going to try a 10 a.m. stream, and we'll see. Typically, most of our streams, we've been having 10 to 14 people. So if we move to 10 a.m. and we're above that, then we'll probably stay at 10 a.m. If we're below 10 people in the stream on Friday, then we'll stay at 1 p.m. But if I do hear back from more people that they prefer 1 p.m., then I will keep it at 1 p.m. All right, that's it for today, folks. Thank you very much for coming out, and we'll see you again on Friday. A big thank you to Waterloo Region District School Board for sponsoring this video.